So when we talk about power, we want to relate power to shape. And we can relate the square powers to a shape. And the shape is a square, which kind of makes sense. So if I square something, so if I have 3 meters squared, I get 9 meters squared, or 9 square meters. That means that my shape has an area of a square, okay, 9 squares. Okay, so if I have the base is 3, 3 times 3 is going to give me 9, and the shape is going to be a square. When I talk about cube, okay, cubic powers represent cubes or volume. So if I have 3 cubed, I can make a cube that has side 3 by 3 by 3, which gives me 27 actual cubes. Okay, so when we think of cubing as a power, we should be thinking volume, okay, or the shape should be cubes. When we start talking about higher powers, though, it starts getting a little bit hard to conceptualize. So we're going to avoid that for now. But there is things called hypercubes, and we can actually go into more dimensions. We actually need more dimensions if we're going to go past a cube. Because for a cube, we have length, width, height, and depth. But we need one more dimension if we're going to go to power 4. So practicing multiplying, dividing with exponents, what we can do is, if the bases are the same, I can just count the exponents. So I've used 5 twice here, 4 here. It's connected by times, so I'm using 5 6 times in multiplication. Remember that powers are now a different kind of math. They're not times. Okay, now I understand that it's related to times, but it's like how times is related to addition. Multiplication is repeated addition, but times and add are different. Powers are repeated multiplication, but times and power are different. So here we have base 3. We use it 5 times. We use it here 7 times. We're connecting it with times, so we can count them together as using multiplication 12 times. So even if we don't know the base, we can do the same thing. Although we don't know what we're multiplying by, we know we did it 12 times. Now here, be extra careful with this because powers and plus do not mix. We have to keep them separate. There's nothing we can do here. Okay, that's it. Okay, we never try to do anything with powers and plus. Powers and divide, on the other hand, work. This is just 5 times 3 divides. The divides cancel out with times, and I have 2 extra times. Here we have more divides. So how would I show extra divide? Well, I could show it like this. I can just show it as 2 extra in the bottom. And make sure you remember that if you cancel with times and divide, you're always left with 1. That's called the multiplication identity. Okay, if we cancel with add subtract, we get 0 because 0 is an adding identity. So we can show it like this. So some people have said, well, if I can do 5 minus 3 gives me 2, why can't I do 3 minus 5? And we actually can, but if we do 3 minus 5, I'm going to end up with negative 2. What does negative 2 mean? Well, the negative just means I have more divides. So really the negative is counting how often did I divide by a. I divided by a twice. Well, that's what this exponent, this fraction here, is showing. So that is perfectly consistent.